Okay, I wanted to continue looking at problems on the second page. Number 11 says that BC is tangent to circle A at B and to circle D at C. If AB is 15, BC is 24, and DC is 8, find the length of AD. So let's find the length from the center of circle A to the center of circle D. All right, so we're going to have to think about some of our properties here. And let's just go ahead and draw in that segment they want us to find the length of. They want us to find the length of AD, so I'm going to go ahead and draw that in. And then I'm going to fill in what I do know from my theorems. All right, I know that this is a radius and it touches the tangent point here, so that's a 90-degree angle. I know that this is a radius and it touches that tangent right there, so that's also going to be a 90-degree angle. Okay, I know that AB is 15 units long. I also know that BC is 24 units long. And then I know that DC is 8 units long. Okay, so the question is, how long is AD? Okay, well, let me show you a little trick here you can use to find the length of AD. Let's go ahead and draw on a rectangle here. I'm going to draw me in a rectangle there, make this a 90-degree angle, that's a 90-degree angle. Okay, so we know that opposite sides of rectangles are congruent. So if this is 24, then this is going to be 24. So we can make that 24. Okay, also, if this is 15, and this is 8, I know that if I added 8 plus whatever this is, that would total 15, okay? Or if I subtracted 8 from 15, that would give me this over here. So if I do 15 minus 8, that's going to make this little segment right here 7 units long, okay? Now realize what I've done here is I've created another 90-degree triangle. I've got a right triangle down here. So if this is 7 and this is 24, and I want to find the length of AD, this would be the hypotenuse. So I could say 7 squared plus 24 squared equals AD squared. Okay, guys, you're just using Pythagorean theorem there. All right, so that is a Pythagorean triple, and AD is going to be 25 units long. Okay, 7, 24, and 25 are Pythagorean triple, so AD is going to be 25 units long. All right. Okay, let's move on down to that next diagram. It says ED and CD are tangent to circle O, and then we need to find the following angles. So again, let's fill in what we do know from all these theorems that we've learned. We know that this would be a 90-degree angle because the radius touches the tangent line. This would be a 90-degree angle because the radius touches the tangent line. Okay. I know that this is going to be congruent to this because they're both radii, and I know that this is going to be congruent to this because they're tangent lines touching the circle at 2 different sides from the same exterior point, and we learned that those are congruent. So essentially what we've got here are 2 congruent triangles by side angle side, side angle side, okay? So if this is 34, this is 34, okay? Using my interior angle sum theorem, I would know that this is 56 degrees, and this would also be 56 degrees, okay? These are vertical angles, so this would be 56 degrees, all right? The 3 of these added together, this one plus this one plus this one, they form a straight line, so they would have to equal 180, and so that would make this angle right here 68 degrees, okay? So let's answer some of these questions over here based on what we just filled in. There's more that we could fill in, but for right now, I'm just going to stop and then answer some of these. So BOC, again, is going to be 68 degrees, okay? OBA, so this is going to be an isosceles triangle, okay, guys? So I know that this angle right here is 56 degrees. So if I did 180 minus 56 and divided that in half, that would make this 62 degrees and this 62 degrees, okay? So that's going to be 62 degrees. All right, angle AOE would be 180 minus 56, which is going to be 124. because it'd be the 180 minus the 56. Okay, CDO is going to be 34 degrees. And then EOD is also going to be 56 degrees. Okay, guys, so it's just a matter of filling in what you're given, write in things that you know based off of theorems, and then just kind of justify and reason from there what the measures of the other angles are going to be. All right, now at the bottom down here, we're getting to the measure of angles, central angles, and arcs. Remember that arcs and degrees are the same measure as the central angle that intercepts them. Okay, so again, if this arc is 70 degrees, this angle would be 70 degrees. These are vertical, so that would be 70 degrees, and then this arc would be 70 degrees. Okay, these three angles right here are all going to be 180 degrees. So if you took 180 minus 70, you get 110. Divide it in half. That's 55. That's 55. So that'll give you the measure of that those two angles right there. If you do 180 minus 70, this is going to be 110 up here. So based on all that, we ought to be able to fill this in pretty easily. The measure of EOF is going to be 70 degrees. The measure of EJH, arc EJH, that's a semicircle. It's going to be 180 degrees. The measure of arc FH, you just add those two together, it's 110. FOG, angle FOG is going to be 55 degrees. Arc JEG, that's that major arc. I'm going to add 180 plus 55. That's going to give me 235 degrees. And then major arc HFJ, I can take the 180 plus 110, and that's going to give me 290. All right. Next one, I'm going to let you guys work out. The answers are on the Google Classroom, but I did want to go over some of those involving arcs and central angles. Hopefully the Khan Academy video helped some of you that still had questions. But just remember that the arc, when it's intercepted by a central angle, is going to be the same measure as the central angle. And that should set you well for those type problems. All right, very good.